We learned about exponents really briefly. Do we remember, if you have x squared times x to the fourth, what's the rule? Same base, what do you do with the exponents?
You keep the base,
Okay.
and then you add the exponents.
Right. Because there's 2 factors of x multiplied by 4 more factors of x. How many factors of x do I have? 1, 2, 3, 4, 5, 6. 6 of them. What about division? X to the 7 over x to the third power. What do you do? What's the rule, Ray? What's the rule for that? Subtract those exponents. How come? Because you've got 7 factors of x on top. You've got 3 factors of x on the bottom. You just cross out the 3 of them, right, that are really ones. You've got 4 factors of x left. How about something like this? X to the third power raised to the fourth power. This is x to the third times x to the third times x to the third times x to the third. Well, how come? Right, we're multiplying, logically multiplying those to get there. And I think the last rule we had was if you have something like this, what do we get now? Well, how does this rule work? How does it work, Anne-Marie?
Do you multiply?
Yeah, I want somebody who knows, not going to ask me. What is it?
You distribute the exponent to each of the.
Yeah, it's like distribution. It's like raising x squared to the third power and y to the fourth to the third power. So what do we get? X to the
power
6, y to the 12. Those are the rules, remember?
Yeah.
And if you don't remember, the rules are on that paper right there. So what's new today? First of all, remember how 0 exponents work? What is x to the 0 power? What is it?
1.
Okay. Anything raised to the first power? Yes. Just tell her yes. Can they come in just a few minutes though? Okay. Anything to the 0 power is what? Now what about negative exponents? Negative exponents. Now you see negative exponents when you've done scientific notation. Who knows what this means? You know, Mons? What does that mean?
Don't you divide by the number, so if x was 2, you would go from 1 to 1/2.
No. That's a fractional exponent. No, we're just looking at a negative exponent. I need somebody, I know what it means. What does it mean?
You add a decimal and you add 0.
No. This says a negative exponent. If you think of it as a frowny face, aren't negative people sad? You know why this negative exponent is sad? Because he's in a numerator. Think of him, right? Isn't he in a numerator? You know what would make him happy? Being in a denominator. Once you can put him in the denominator, see how he's not negative anymore? He's positive. He's happy. So a negative exponent moves you. What if you're already in a denominator? He's unhappy. Where does he want to be? He wants to be on the numerator. So negative exponents kind of move where you belong. If you're in the bottom numerator, you go denominator, go to the numerator. If you're in the numerator, go to the denominator. They can get a little bit more complicated. Just making something up here. Now, how do you work something like this? Well, what are the rules? The rules are keep the same base and then subtract. What's negative 3 minus 2?
Negative 5.
So negative 5. What about y's? What's going to happen to the y's? 2 minus negative 4.
6.
Negative 4 minus 5.
Minus 10.
So, and now I don't see a fraction anymore, but it really is a fraction. How would I write this so that I have no more negative exponents? What do you think? You're very, very close here. These are negative, these are negative. So see if I put them on the bottom, their signs are no longer negative, and the y to the 6 is a positive exponent. He stays in his numerator. So negative exponents don't mean the number is negative, it just is a location in between. All right, so that's the very quick rule on doing math stuff. I want to quickly do what we're learning new about scientific notation. Scientific notation, a number like this is scientific notation. This is a number between 1 and 10, and this is 10 to a power. Multiply. Is this scientific notation? No. What's wrong with it?
Decimal.
Right? So I can fix it. So I want it to be a number number in between 1 and 10, so I took the decimal here and I moved it. What happens to my power of 10 if I want an equivalent number? You know, Rachel, she's like, go to the 8. It would go to the 8th power. How come? Think about what this means. This means you've got 7 zeros after it, right? When I move my decimal, now I got to move it back 8 places, right? If you move it 1 to the left, you got to multiply by another power of 10. So that's one thing you need to know. Now, if you're multiplying numbers, here I've got an example. 8.5 times 10 squared times 1.7 times 10 to the 6th. This is a times, isn't it? Isn't that what that means? I am multiplying 4 numbers. Commutative property multiplication says you can multiply numbers in any order you want. So I'm going to change the order that I multiply them. And I'm carefully just saying, when am I putting an X and not? I could have put an X all the places. So I just mix them up a little bit. What is 8.5 times 1.7? Let's find out. I already did it in the last class. I'll do it again. 14.45. Times, what's 10 squared times 10 to the 6th, using the laws of exponents. How many factors of 10? 8. Ooh. So do you have to expand these out first and then multiply? No, in fact, don't. Now, is this scientific notation? It kind of looks like it, but is it? No. What's the problem? Right? I got to move that over to the left. Well, what's that going to do to my power of 10? Move it 1 to the right. Okay? Now let's look at the division. I know I'm going a little fast here. Let's look at the division. You do the same thing. Let's divide those numbers first. Give me a second. 5.891 divided by 4.3. I think what is this? 5.891 divided by 4.3. And I'm getting 1.37 times. Now we're going to do this division. That's 10 to the minus 3. What's a minus 3? And that's 10 to the minus 7. What's minus 3 minus negative 7? Is this scientific notation? Yes. It is. I'm done. So multiplying, you multiply the numbers, then multiply the exponents, and then see if you need to put it into scientific notation. Division, divide the numbers, divide the powers, and then see if you need to put it into scientific notation. And that is like a 50-cent tour. That's about as fast as I can do it. Now, that's fast. And I am going to post this little video, but I found some really good videos on my class summary page. And in case you don't know what I'm talking about, my class summary page, you go to my website, click on class summary, you look for today's date over here. I've got 3 different videos on negative exponents. Some are simpler and they get a little bit harder. They're real good. This one on multiplying, dividing scientific notation is a fantastic one. The person who did it did an excellent job. So this is flipping the classroom. I gave you kind of a quick little brief look. You've got some notes, and now you have videos to kind of learn how to do this on your own. Anybody up for this challenge? Yeah. Who's up for it? I'm up for it. Raise that hand. Everybody's not. Hey, everybody, raise those hands. Yeah, we are so up. You're up for it. I know you are. So because you can. And it does get us out of a little bind with the timing, but it's also teaching you how can I do math without somebody sitting right next to me holding my hand all the time. You can do this on your own. So again, I want you to try this for not next class. It's not due next class. It's due the class after.